Last class we start chapter 4, electric charge and electric current. So last class we have learned the formula for electric charge, denote the letter, unit we have learned. No? So just today first you revise the formulas, unit, and after that we can start the lesson. First electric charge. What is the unit of electric charge? Coulomb is the unit of electric charge. But the electric charge denote the letter Q. Q is the electric charge, denote the letter electric charge Q. What is the unit of electric charge? Coulomb is the unit of electric charge. Then two formula we have learned. One formula is Q equal to N E. Another one formula Q equal to I into T. So Q, what is Q? Q means what? Electric charge. N, number of electrons. E, electron. Then Q, electric charge. I, electric current. And T, time. By using these two formulas, last class we have learned how to do problem. By using these two formula. So suppose here current, charge is given, time is given, current. They ask me what formula? I equal to Q divided by T. Suppose time, they asked, charge given, current given, time. Time is, the formula is T equal to Q divided by I. Like this, like that we can change the formula and we can do the problem. And we should write the unit which question is asked, that only. Suppose here you are calculating time. So what is the unit of time? Second. So answer you will get near that you have write the unit second. Suppose here electric current. Current you have to find out. What is the unit of electric current? Ampere is the unit of electric current. Near the answer, you have to write the unit ampere. And here also charge, you have to find out charge. The formula for charge, I into T or N E. Which question given, according to that, you have to take this formula. And you have to find electric charge means just find out the answer and write the unit, Coulomb unit you have to write. So then electric current formula also you have learned. Electric current denote the letter I equal to Q by T. Like that you have to, last class we have learned. No? Q means electric charge, I electric current, T time. What is the unit of electric current? Ampere is the unit of electric current. What is the unit of electric charge? Coulomb is the unit of electric charge. What is the unit of time? Second is the unit of time. Now, the electric, how we should find, which instrument used to find electric current means ammeter. So, which instrument? Ammeter is used to measure the electric current. So, which instrument used to measure the electric current? Ammeter is used to measure the electric current. Today, we can learn about the EMF and the current will measure. No, what is current? What is current? Flow of charges or current. So, two charges we have learned already. What are the two charges? Positive charge and negative charge. How we should mention? See the positive charge, a line. This is the positive charge and small line is the negative charge. So, this is the cell. So, one cell consists of positive terminal and negative terminal. There are two terminals, positive terminal and negative terminal. This we will say as a cell. Combination of cells are called battery. So, battery means what? Combination of cells. See, combination. Combination of cells are called battery. So, this we can write BT. Battery short form we can write BT. So, cell means what? Two terminals are there, positive terminal and negative terminal. And combinations of cells, combination, more cells are there. One or more cells only is as a battery. So, the current passes from positive terminal to negative terminal. So, the electric current, how we will measure the electric current, which instrument? By using ammeter. And the cell means there are two terminals are there. What are the terminals? Positive terminal and negative terminal. So, the positive terminal you have mentioned a big line and the negative terminal mentioned as a small line. The combinations of cells are called battery. So, battery means what? The combination of cells are called battery. The next we can learn about EMF. What is the full form of EMF? Do you know what is the full form of EMF? Electromotive force. So, EMF. EMF means what? Electromotive force. electromotive force. Next, we are going to learn about potential difference. So, potential difference. So, this one EMF. Next one, potential difference. So, first we can learn about EMF. So, let us consider a horizontal pipe. You all know about horizontal pipe. Horizontal pipe. Now, inside the pipe, water is there. Okay. Horizontal pipe, inside the pipe, water is there. But it does not flow anywhere. Why? It is in horizontal. Now, top to bottom means it will, water will flow. But here horizontal, inside the pipe, water is there. It does not fall out. Then, by using the pump, suppose this, by using the pump, we can this water will pass through out, okay, by using the pump. So like this only it is electric current also. Here, suppose here battery. So battery only we are using for using the pump. Here some force is there. The water want to pump one side to another side, means any side means some force is there. That force only will say as a electromotive force. So here also, see, suppose this light on the globe. See, this bulb glow means here what is there? Charges are there. Now I told the combinations of cells are called battery. So one cell consists of two terminals, positive terminal and negative terminal. The current passes from positive terminal and it goes through negative terminal. Now, so here some force is there. Some force is there. From the battery only the current will pass. From the positive terminal the current will pass and this light in this bulb goes. Now, so here some force is there. That force will be as a electromotive force. Some work is done inside. Okay. So what is conductor? The current passes is called passes through the wire is called conductor, and insulator means does not, the current does not pass insulator. Now here these are the conductors. Now this conductors, copper wire, so aluminum wire, these are the conductors. So here EMF means what? Some force by using the water flowing through this pipe by using the pump. No, like this here some pushing force is there. That force only EMF. EMF's full form electromotive force. The EMF denote the letter E, equal to work done divided by charge. W means what? Work done. Q means what? Charge. Okay, work done per unit charge only. What is that? EMF. Work done per unit charge only. What is that? EMF. The unit of EMF is volt. What is the unit of EMF? Electromotive force. What is the unit? Volt is the unit of electromotive force. Denote the letter E. What is the formula? Work done divided by charge. Now we can study the unit of it. So EMF unit I told. What is the electromotive force unit? Volt is the electromotive force unit. What is the unit of work done? Joule is the unit of work done. So what is the unit of work done? Joule. Joule is the unit of work done. Joule is the unit of work done, and the unit of charge is Coulomb is the unit of charge. Now listen here. The formula for electromotive force is E equal to W divided by Q. W means what? Work done. Q means charge. So what is the unit of work done? Joule is the unit of work done. And what is the unit of electric charge? Coulomb is the unit of electric charge. What is the unit of EMF? Volt is the unit of EMF. Okay. So these are about the electromotive force. Just you have learned this formula. And next we are going to learn about potential difference. This also same. Potential difference. See, I am writing here potential. Potential difference. Potential difference denote the letter V. Potential difference denote the letter what? V. Potential difference denote the letter V. EMF electromotive force denote the letter V. And the potential difference denote the letter V. The formula same, V equal to work done divided by charge. What is the formula for potential difference? V equal to work done divided by charge. Same formula, EMF denote the E and potential difference denote the letter V. Now what is W means what? Work done. Q means charge. There is study now. What is the unit of work done? Now you can say what is the unit of work done? Joule is the unit of work done. What is the unit of charge? Coulomb is the unit of charge. So here also the unit of potential difference is volt. Unit of EMF also volt. Unit of potential difference also volt. Now voltmeter. So this potential, how we should find your potential difference? So that here the voltmeter always connected in parallel circuit. Okay. So now this battery, bulb and voltmeter. We mean so voltmeter. This one voltmeter. What is the use of this voltmeter? We can see what is the use of this voltmeter. Voltmeter is used to find the potential difference. Potential difference is voltage. Okay. Voltmeter is used to measure the potential difference. What is the use of ammeter? Ammeter is used to measure electric current. What is the use of voltmeter? Voltmeter is used to measure the potential difference. Suppose here this is the positive terminal, now this connection, and the positive terminal of the voltmeter and the positive terminal of the battery want to connect. Then negative terminal of the battery and negative terminal of the voltmeter we should connect. Like that only we should connect. Always you should connect this voltmeter in parallel in the circuit, not series, parallel in a circuit voltmeter. Now here, what is the use of battery? Here this flow of charges. Here only charges are there because of some force, charge, and some work is done here. Now, some work is done in this circuit, then only what is that? This light, this bulb will glow. Okay. So here, what is the use of voltmeter? To measure the potential difference. What is the formula to measure the potential difference? V equal to work done divided by charge. Suppose 10 joule work done is done here. Work done equal to 10 joule. And charge Q equal to 2 coulomb. It is given. You have to find the potential difference. So how will you find? So V equal to, what is the value of work done? 10 divided by, what is the value of charge? 2. So you will get V equal to 5. Just to divide this, you will get to 5. What is the unit of potential difference? Volt is the unit of potential. So, the 5 volt will get the value. Like this formula problem comes, just to write the formula and you should calculate. From this, suppose here potential difference given, charge given. You have to find work done, you have to find. What is the formula? You have to find work done. What is the formula? Here potential difference is there, charge is there. You have to find work done. So W equal to V into, by using this formula you can find it. W equal to V into, suppose you have work done, you have to find out. So the potential difference is given 5 volt. V equal to 5 volt it is given. And the charge it is given Q equal to 2 coulomb. Like that charge it is given. You have to find work done. See the potential difference given, charge given. You have to find work done. So W equal to, just to substitute the value 5 into 2. So you will get to 10. What is the unit of work done? Joule is the work done. So you will get to the value 10 joule. Answer. So like that, by using this formula you have to. So today we have learned about EMF and potential difference. The next one, we have to learn about resistance. Resistance. Resistance denote the letter capital R. Resistance denote the letter capital R. What is the unit of resistance? Ohm is the unit of resistance. What is the unit of resistance? Ohm. The spelling O-H-M. What is the unit of resistance? Ohm is the unit of resistance. What is the denote the letter of resistance? R is the denote the letter of resistance. And ohm is the unit of resistance. So we can write ohm like this also. If you don't know to write this, you have to write O-H-M. Spelling also you have to write. Okay. So the resistance denote the letter R and the unit of resistance is K. Now we can study. See like this you can draw the resistance. This resistance. And variable resistance. This is the variable resistance. Rheostat. See, resistance, variable resistance, rheostat. Rheostat spelling they are given. So the resistance, variable resistance and rheostat. So like that here, resistance denote this everything denote the letter O. The unit also, what is the unit? Ohm is the unit. So the resistance, what is the definition for resistance? What is resistance? See, in a circuit, we can draw on circuit. The resistance, the battery, the switch, now the circuit closed. From the positive terminal only the current passes. Here this is the resistance. This battery BT, short form BT, and switch K. And this resistance. From this resistance, these two ends of the resistance only we can find potential difference. Potential difference denote the letter V. So already we have learned this the two terminals in between only the potential difference V we can calculate. Okay, potential difference V. Battery BT, we can write a short form BT, and key K. Now what is resistance? See, resistance is a measure of opposing offers to the component. Here what are the components of the resistance? Battery, key, these are everything components in a electric. See here the flow of current. No, here in the circuit closed means what happened? The flow of current in a circuit. So the circuit closed now. So the flow of current in a circuit. So resistance is a measure of oppositions offered to a component, offers to a component to the flow of current. This is the resistance. Okay. Resistance, definition for resistance. The resistance is a measure of opposing offers to the component to flow of current. So now listen, here what are the components used in the circuit? Resistance, battery and key. Now we can write the formula. Ohm's law formula you all know. Ohm's law, the voltage, relation between the voltage and current only. What is that? Ohm's law. Ohm's law means what? Relation between the voltage and current. What is Ohm's law? Ohm's law we can learn after. Now Ohm's law means what are the relation? Relation between the potential difference, you know, denote the letter what? B. And the electric current denote the letter I. These two relation only will say as the Ohm's law. Okay. Now listen, Ohm's law we can learn. When a steady current denote the letter I. When a steady current flows through a conductor. Conductor means what? Wants to conduct electricity. So the steady current flows through a conductor is directly proportional. This is the directly proportional. A steady current I flows through a conductor is directly proportional to the potential difference between two ends. Here two ends are there. Now potential difference between two ends. So Ohm's law, the steady current flowing through a conductor is directly proportional to the potential difference between two ends. Okay. So the Ohm's law is the relation between potential difference and the current. Now by using this formula we can learn the Ohm's law. So the steady current I flowing through a conductor is directly proportional to the potential difference between two ends. From here we can write V. Here proportional symbol now. So if you write equal to means one variable we have to write. So that variable is R I. So V equal to R I. From this we can calculate current also we can calculate. See potential difference resistance given means the current formula is I equal to V by R. Suppose here current given and potential difference given means the R value we have calculate R equal to V by I. Like that we can calculate. Now say V means what? Potential difference or resistance. I electric current. So the unit of potential difference what is that? Volt is the unit of potential difference. What is the unit of resistance? Ohm is the unit of resistance. What is the unit of electric current? Ampere is the unit of electric current. So you have to learn each letter what is that, and each word unit also there. So just you have to learn. Now regarding this problem also given. So the resistance given and current given means what is the formula you have to use? V equal to R, right? Now suppose here resistance 5 ohm resistance is given. Just listen, the resistance R equal to 5 ohm. Now the current I equal to 3 ampere. So you have to calculate resistance given, current given, you have to calculate potential difference, you have to calculate. So our formula is V equal to Ri. So just you have to multiply 5 into 3. So V equal to 15. What is the unit of potential difference? Volt is the unit of potential difference. Volt VOLT also you can write, or V also you can write. So like that you have to find out. So today we have learned about EMF, potential difference, resistance. 3 also has formula. Just you have learned well the formula and denote the letters, unit. If you have any doubt you can ask. So just you have to learn very important lesson, this lesson, and we can mark the question, students. Take your book. Room letter 6. Question number 4. Define electric current and give its unit. Page number 41. The measurement of electric current. The second line. Current is the rate of which charges flow past a point on a circuit. Just mark it. And formula I equal to Q divided by T. The unit, the SI unit of current is ampere. The symbol is A. That much. Next question, question number 5. State Ohm's law. That book not given, just you have to write this. At a constant temperature, a steady current flowing through a conductor. At a constant temperature, a steady current flowing through a conductor is directly proportional to the potential difference between the two ends of the conductor. So once again I am reading. At a constant temperature, a steady current I flowing through a conductor is directly proportional to the potential difference V between the two ends of a conductor. Next line you have to write I is proportional to V. Okay students, today 2 questions you have to mark. Define electric current and state Ohm's law. Just you have to study and write these 2 questions. And so many formulas, unit and all we have learned in the book. Everything it is there. Just underline and study. Only formula, denote the letter and